Good afternoon, everyone. Hope all is well. Hope everyone's doing all right. We'll give everybody a chance to get in, and we'll get started.
You got my email?
When did you send it?
Earlier today for the campus.
Okay, I haven't looked today, so I'll check it out.
Are we still going on Friday? Tomorrow?
Yeah, I should be in there.
Okay. I'll see you at 9 when 9 tomorrow.
Okay, so make sure you you have your questions already ready for us to go through. All right.
Okay. I was actually going to talk about the first two parts of chapter 7.
Okay, as long as you have your questions ready, we'll be able to rock. All right, so hope everybody's doing great. Everybody's doing all right. Didn't get a chance to check out 7.3 yet to see if I want to go through it. So we'll just go ahead and do 7.6. We have to do 7.6 anyway, so it's not a big deal. So 7.6 talks about vectors. All right, just trying to write stuff a little bit neater. So vectors would be quantities that involve both the magnitude and direction. They're called vector quantities, just vector for short. Hold on 1 second. Oh yeah, you loud, but that was it. Sorry about that. Had to catch somebody from staff before I lost them. So let's look at this example. So you are driving, and this is just an application, real life application of a vector. You are driving due north at 50 miles per hour. So the magnitude is the speed, which is 50 miles per hour, and the direction of motion is due north. So that's what we're talking about, having direction and magnitude. Scrolling up. All right, quantities that involve magnitude but no direction are called scalar quantities. So scalars for short. then the scalar has only a numerical value. So an example of a scalar is the temperature of the room that you're in. Right. All right, next one, a line segment to which a direction has been assigned is called a directed line segment. Right now, we're just going through terminology, setting our foundation so that when we see these different terms, you know what we're talking about, especially when it comes to scale and magnitude. So example of that, you know, we're talking about P to Q, or something like this. Notice we have our initial point at P, and we're going to Q with our terminal point. You see in the purple, that's how you would actually symbolize it, or write it as a, I would say write it as a symbol. I guess that's good enough. Anyway, PQ with the arrow going from P to Q. Go down here. That's how you use these symbols. I'll go too far. Okay. So the magnitude, going back to the magnitude of a directed line segment is its length. So we're talking about the distance from P to Q. You see the symbolism now. We have the two lines, the double lines on each side of P and Q. That represents the magnitude. So we're not going to have any negative magnitude. So if you end up with a negative magnitude, somewhere we're wrong. Vectors are often denoted by boldface letters. Try my best here to signify that V is boldface. But yeah, when you see it in the book or in math lab, your vectors will be boldface. If I go too far, let me know. So we're looking at finding the magnitude now. So we want to know the magnitude of vector u. It's the same as the distance formula. We're looking at the square root of x2 minus x1 squared plus y2 minus y1 squared, where our initial point, x1, y1, coordinates of our terminal point, x2, y2. All right, so let's look at this next one. Oh, well, this first example under trying to find the magnitude. We have vector u, where our initial point is -3, -3. Terminal point is 0, 3. So once you've established what your terminal point is, what your initial point is, you can go ahead and plug them in accordingly. Plug them to the formula accordingly. That's what I did right here. So x2 was 0, x1 was -3. Make sure you don't lose a negative. Y2 is 3, y1 is -3. That gives us 3 squared plus 6 squared, that's under the radical. 9 plus 36, 45. And then you want to simplify it as much as possible, breaking down that 45 into 9 times 5, taking the square root of 9, which is 3, leaving the 5 under the radical. So our magnitude would be 3 squared root of 5, written in the simplest form. All right. Any questions? Any questions? Very good. All right, so multiplying a vector by any positive real number except one changes the magnitude of the vector, but not its direction. Multiplying a vector by a negative number reverses the direction of the vector. All right, so next, looking at the I and J unit vectors. So vector I is the unit vector, right there. The unit vector whose direction is along the positive x-axis. Vector J is the unit vector whose direction is along the positive y-axis. I don't know the purple. Okay. Okay. All right, so representing vectors in rectangular coordinates. So vector V, if we're talking about going from 0, 0, 0, which is your origin, to any coordinate. So we're just saying generically AB is represented as AI plus BJ. So the real numbers A and B are called the scalar components of V. A is your horizontal component, B is the vertical component. AI plus BJ is called the linear combination of the vectors I and J. So the magnitude of vector V, if it's given to you in this form, is just the square root of A squared plus B squared. You think so? Oh yeah, see the wall block. You say you saw what? Oh yeah. Mhm. Gotcha. Okay, cool. All right, let's see what we want with this. Oh, okay. So vector V with initial point P, terminal point Q, just like we mentioned before, is equal to the position vector. Is everybody done with that green? So it's another way of rewriting it, A and B. And that's why here A and B is x2 minus x1, y2 minus y1, which goes back to your uh, distance formula that we were talking about earlier with the magnitude. So mhm, mhm. Yeah. Really your spring break flow. All right, so let's see if we can implement this. We have let V be the vector from the initial point P with coordinates of 3, -1, then terminal point Q with the coordinates of -2, 5. And we want to write in terms of I and J. I have some runs to make out the class, so nice. So as far as our labeling is concerned, P is our initial point, so that would be the coordinates x1, y1, Q, terminal point x2, y2. And we're leaning on the formula that I just gave you. X2 minus x1 is going to be in front of I. Y2 minus y1 will be in front of J. Just make sure you substitute in accordingly and make sure you don't lose any of your negatives. So we have -2 minus 3, and then 5 minus -1. And so in terms of I and J, that would be -5I plus 6J. Mhm. Mhm. Yeah, I understand that struggle. All right, are we good? Let's scroll up. All right, so next we're looking at adding and subtracting vectors. So this goes back to really just combining like terms. A lot of times dealing with vectors, you're starting to see how the basic algebraic skills come back into play. So they established V, vector V, as 5I plus 4J, and then vector W as 6I minus 9J. Then they tell you to add V and W. All you do is combine your like terms, add your I terms, add your J terms, and that will be your answer. So 5I plus 6I is 11I, 4J minus 9J will be -5J. Same thing if you're talking about subtracting your vectors, but always when subtracting, you have to add that element of distributing the negative to each term that follows in the parentheses. So that's what we do here. That'll be 5I, excuse me, plus 4J minus 6I plus 9J. Then combine the like terms will give us -I plus 13J. All right, here we go. All right, scalar multiplication. Same thing that you've done in the past. Our vectors are still the same. V is 5i plus 4j. W 6i minus 9j. I have 6v, 6 times v, so that means I'm going to multiply 6 times each term or each component of your vector. So 6 times 5 is 30. 6 times 4 is 24. So 30i plus 24j. All right. Next one, 4v minus 2w. Distribute the 4 to each term in vector v. Distribute -2 because it's minus 2w. So you distribute -2 to each term or each component of your vector w. That'll give us 20i plus 16j minus 12i plus 18j. And of course, there is the thunder that me and your one classmate will have to walk in the rain. That signifies that we have to walk in the rain. What'd you say? So yeah, so you 20i minus 12i, 8i, 16j plus, yeah, I brought my stuff. 16j plus 18j should be 34 plus 34. I think I made a mistake and erased that. So it should be a plus 34j. Questions, questions, questions. Huh? Oh, okay. About to say, if you see something, let me know because I'm human. I can write something wrong. Are you still copying B though? Okay. Okay. All right. So the zero vector, the vector whose magnitude is 0, has no direction, and it can be expressed as 0i plus 0j. Oh yeah. How much is left with it? Oh, okay. Yeah. Oh. It's getting real dark too. Oh yeah. Wow. Anybody holding on to this top part? Can you scroll all the way up? Okay, so properties of vector addition and scalar multiplication. So it's very similar to what we've done with just regular numbers. You know, we talk about commutative property, social property, identity properties. So u plus v and v plus u are going to be the same. U plus v, then adding w, or v plus w, then adding u won't be the same. So first one's commutative property, second is social property. Then u plus 0 and 0 plus u still going to be u. U plus negative u plus u still be 0. And so you see in the red box, u and v are going to be referred to as vectors. C and D are scalars. I meant to write that first, but I wrote it down there, so you still got it. And then when we scroll down to number 5, you'll see that we have scalars being involved, but give you a chance to write 1 through 4 first. So C and D are introduced, and they are scalars. So C times D times U, same thing as, huh? Okay, all right. Oh, that's different. So C times D times vector U is the same thing as D times vector U times C. And then C times the quantity of U plus V. You can distribute that vector, that scalar to each vector. Are you good now? Okay. And then C plus D times U is the same thing as CU plus DU. 1U is the same thing as U. 0U is the same thing as 0. And then if I want to take the magnitude of C times V, so don't forget C is a scalar, V is a vector. If that's the case, I can pull the scalar out, take the absolute value of that, and just find the magnitude of V separately, and then multiply that afterwards. It just depends on the complexity of what's going on. If they're very large numbers or whatever the case may be, this may be an easier route to go. It's always about making things easy so you as possible. Yeah. All right, so we scroll up. I think this is the last thing we're doing. Oh, okay, you're just emphasizing that number 10. So I'm okay with these properties before I go to the example? Okay, so if we have vector u is 2i minus 5j, and we want to find the magnitude of negative 2u. So we're applying the property of number 10. So that means I can take number 2 out of the magnitude process and just take the absolute value of negative 2, but it will be positive 2. And then take the magnitude of u by itself. And don't forget here, is how we find the magnitude of u when it's in this form of 2i minus 5j. Take the square root of 2 squared, take the square root of 2 squared and negative 5 squared. So 2 squared is 4, 5 squared, 25, that's the square root of 29. So 2 times the square root of 29 would be the magnitude. Actually, all right, is everybody good? Everybody good? I'll go to the next thing. So let me see what's left out of 7, 6 magnitude. Vector. Okay. So what I'm gonna do is I'm gonna pause right here. We can pick up, since I broke it up in my notes before, we'll pick back up here next class. I know some of you aren't in a rush to jump more into chapter 7 anyway, because y'all got some work to do, right? Some people needed that extension, which is fine. And I want to try to beat the rain, try to save me and your classmate from this rain. You already started? Yeah. So we're going to
Bye.
close out. All right, sir, take care.
Bye. I'll see you on. I guess I'll see you on Monday. I'll have my questions ready.
Okay, all right, not a problem. All right. So anybody have any questions before we close out? Okay, have a good weekend. You have a good one as well. So if you guys are good, I'm good. I'll see you next class. Have a great weekend. Be safe. And we'll pick up back here next class. Take care.
Thank you very much.
Thank you.
Bye.
Take care. Yeah, thanks. Appreciate it, sir. I'll try to stay dry.